Dear participants, I welcome all of you in this lecture of data visualization using Matplotlib and Seaborn. So this is actually part of descriptive statistics, where we used to plot different type of charts and graphs so that we could have a better understanding of our data set. In last class, we discussed writing pandas data frame to file. We had seen how we can merge two different data frames, pandas data frame. Then we discussed on topics like inner join, left outer join, right outer join, full outer join. So we had seen these different concepts, which are very similar to structure queue language, that is SQL, which is a language for database management system. In today's lecture, we will discuss how to plot histogram, bar plot, kernel density estimation curve, box and whisker plot, join plot, violin plot, correlation matrix plot, scatter plot, pair plot. And what is the purpose of these different type of plots? So that we will discuss in today's lecture. So why data visualization is very important, in data science. So representing data graphically helps us to uncover trends, patterns, and communicate findings in a way that is intuitive and impactful. So it provides you different type of trends in your data set and patterns, and that can be communicated to the organization as well. So if you are representing any plot, so that would be more understandable for the organization. Matplotlib is a Python library that specializes in creating visualizations and instrumental in plotting graphs. So Matplot is a very important Python library. The next library which is very important for data visualization is Seaborn, which is a powerful Python library that enhances the process of generating insightful graphical representation of data. So Seaborn enhances graph plotting capabilities by integrating with Matplotlib. So the base is actually the base of Seaborn is Matplotlib. So it is based on actually Seaborn is based on Matplotlib and pandas and NumPy libraries. It is designed as an extension of Matplotlib. It enriches data visualization by offering support for both univariate and bivariate data analysis. So we can using Seaborn, we can plot different type of univariate plots and as well as bivariate, even multivariate plotting. So that we'll discuss what is univariate, bivariate and multivariate plots. Seaborn distinguishes itself through its ability to apply aesthetically pleasing themes to Matplot charts. So it is actually giving certain more aesthetic to Matplotlib charts and plots. And most of the plots will try to draw using Seaborn because it is more aesthetically more better than Matplotlib. So we can divide data visualization into two different categories: univariate plots such as histogram, density plots, box plots and others, and multivariate plots such as correlation matrix, scatter matrix and so on. So univariate plots visualize data with only one variable at a time. So let's say I'm plotting, I want to plot age of a particular data set. Let's say I have a data set such as diabetes prediction data set. So I want to plot. I want to plot the count of age, or you could say frequency of age under different bins. So for that purpose, I would use histogram. So we are actually concentrating on single type of variable at a time. So these plots are used to understand the distribution, central tendency and variability of a single feature within a data set. And what about multivariate plots? So multivariate plots are used to explore relationship between two or more variables simultaneously. So these plots can reveal patterns, correlations, trends and interaction between multiple variables. So if you want to see the relationship between age and blood pressure level, let's say age and uh, you know how age is actually affecting in diabetic data set. So we if we want to correlate two or more features, so for that purpose we will be using multivariate plots. And under this category we are having correlation matrix plots, scatter matrix plots and others that we'll discuss. So now come to univariate plots. So as I told you that univariate plots are actually used in understanding each attribute of our data set independently. So these are certain univariate plot. Let me select the pen first. Yeah. So we are having histogram, density plots, box plots as far as univariate plots are concerned. Now we will focus on histogram and the purpose of histogram, that, and we had already discussed histogram in descriptive statistics as well. So in statistics, a histogram is a graphical representation of the distribution of the data. So the histogram is represented by a set of rectangles adjacent to each other. So each rectangle is actually based on certain beans, and beans are actually buckets. So the beans are usually specified as consecutive non-overlapping intervals of a variable. So it is very important important plot, you could say, or important statistical concept as far as descriptive statistics are concerned. So the focus is here to first create the beans, and if you are not actually if you are using Matplotlib and Seaborn to draw histogram, so they are actually dividing the whole data set into certain beans if you are not providing the beans. And also we can provide beans as well, right? So if we want to distribute a whole data set into certain beans, then we can give beans as well, like in this case. So first we will see how we used to plot Matplotlib. So this is my data set. Let's say df is actually df is equal to panda object, then read csv, and this is diabetic data set. Let's say diabetes.csv. So this is my data set, and I want to plot age and blood pressure both. You can take single features as well, like in this case I am concentrating on glucose only. So there is a feature that is glucose level. So I can use single feature as well. If you want to have multiple histogram, so we can use in this manner. So we need to provide a list of features, like in this case, list of features. So it will give you a histogram of each and every individual features. Like in this case, this one is for blood pressure and this one is for glucose, right? So I have given different colors as well, right? So you can decide different colors as well. Like I have given blue to age and green to blood pressure level, right? So we can change these colors as well. And you might note here there is a line in this case. There is a line here, and what is the purpose of this line actually? So this actually is a kernel density estimation curve. So we can draw a kernel density estimation curve as well. And what is kernel density estimation curve? That we will discuss in next slides. So it is very important curve which is actually based on histogram. And there is one more parameter that is alpha here. Alpha is used to contrast the color. So if you want to make it very bright, or so I would increase this value to 0.8, 0.9 and so on. If you want to make it low contrast, then I will make it 0.1, 0.2 and so on. So in this way, I can have my different histogram plot, right? So now how to draw a histogram for qualitative data, right? So these histograms are actually based on quantitative data. So like glucose level and blood pressure level. So these are quantitative data. Now suppose we are having qualitative data, right? Or you could say categorical data. So how to plot histogram for those type of features? So first we need to group by the data set on the basis of that feature, that is the qualitative feature, right? So that we have seen in last class, how to group a data set based on certain condition. So first of all, I have grouped this feature on the basis of ocean proximity. So I'm using the data set of California housing prediction data set. So in that data set, there is a feature that is ocean proximity. And under ocean proximity, there are different category like inland, island, nearby, near ocean, and less than 1 hour ocean and so on. So these are certain categories under this feature. So first of all, I will group it by ocean proximity, and I would find the total number of instances, right? So I will use cont method. We have already seen there are several methods like mean, max, cont, and maximum, minimum. But this is categorical data. So minimum, maximum is not favorable for that type of group by, since it is a categorical data. But cont is actually used to count the individual instances. So I am counting here this individual category, right? Now I am using bar plot. So using bar plot, we can aggregate the qualitative data, or you could say categorical data. Here I am using one parameter, that is hue. Hue is actually used to mention the categorical data, right? Or you could say qualitative data. So in this case, my different qualitative data are inland, island, nearby, near ocean and so on. So how to find those values? So using index, I can find individual values. We have already seen the purpose of index. Since if you are using group by function, so the categorical data are actually your indexes, right? So here I am mentioning the hue as index, and then y is your values. Values, it means the count. And I'm using the one more feature, one more parameter, that is palette. Palette is used to give different colors to individual bars, right? So if you are not mentioning the palette, so all the bar would be in single color, right? So in this way, we can draw histogram. So actually, what is the histogram? Histogram gives the frequency under each interval, right? So my interval is I'm considering here like inland, less than 1 hour ocean, and island, nearby. So these are my you could say bands or different categories, and I am trying to find the frequencies, right? So these are frequencies values. Now I was talking about kernel density estimation plot. So histogram doesn't differentiate whether the value falls close to the left or to the right or the center. If you are drawing a histogram, so it tells about the count between this in this interval, but it is not talking about whether the value is high at the initial stage, or value is high at the border of this category. Suppose I am talking about 0 to 10. There is a bin 0 to 10. So in 0 to 10, where is the most frequency? Yeah, right. Where is the high number of count in which where high number of count lies? So it doesn't talk about that type of low and high, right? So kernel density estimation curves actually talks about where there are certain low values and high values. So kernel density estimation is a technique that allows you to create a smooth curve, right? A KD plot takes each individual sample value and draw a small Gaussian bell curve over it. So it actually drawing a small Gaussian bell curve, like in this manner. How to draw KD plot? So again, you can use single feature or more than one feature. If you are using more than one feature, so that need to be provided as a list of features. Like in this case, I am utilizing the, I can also use here df2 dot glucose. I can also use in this manner as well, because df2 is having different features like glucose level, BP level, blood pressure, and so on. And if you are using more than one feature, then you can pass color in the form of palette, right? And then again alpha is 0.5. So it means average brightness. You can increase the brightness as well. And both KDE and histogram can you merge into a single plot using the histogram plot, where we can make KDE as true, right? That we have seen. If you are making KDE is equal to true, it means both the plot, that is kernel density, and histogram would be plotted into a single chart or a single plot. Now we'll see how to plot box and whisker diagram. So a box and whisker plot, also called a box plot, display the 5-number summary of set of data, right? We have already discussed during the descriptive statistics. So what is box plot and what are different parameter of box plot? So we are having minimum, first lower quartile, median, third quartile, and maximum. So these are 5 different parameters in a box plot. So minimum, we also used to say it Q0 or 0th percentile. So it is the lowest data point in your data set, excluding any outlier. If there is an outlier, so the outlier will be treated something different. Then we are having maximum. So maximum is also called as Q4 or 100th percentile, the highest data value in your data set. And what about the first quartile? So first quartile is also called as 25th percentile. So and it is also known as the lower quartile. It is the median of the lower half of the data set. So Q1 is actually median between minimum and median of the whole data set, like you can see. So this one is the median between this one and minimum value. Similarly, Q3 is median and maximum, median of this median and maximum. So it says Q1 is the median of left half data set, right? Similarly, this one is the median of Q3 is median of the right half data set, if your data set is in sorted form. And we call it, you could say, upper half of the data set. So how to plot box plot? So we can utilize Seaborn library for that purpose, and it's very simple. I'm plotting 2 different features, glucose and blood pressure, right? I can use single feature as well. So if you are using more than one feature, so you need to provide it in the form of list, like in this case, right? And since I'm using two different features, so I need to provide the palette. One is red and the another one is green. And orient is vertical. So orient, it means vertical. It could have horizontal as well. I could draw a horizontal, box plot as well. So in this way, we actually use box plot. Now we'll discuss joint plot and the purpose of why we are drawing joint plot. So a joint plot is a composite visualization that integrates three plots simultaneously. So three plots, it means there is one plot here, there is one plot here, and the one plot here, right? So it actually display both univariate and bivariate data relationship. So this one is the bivariate data relationship and this one is the univariate. So these two are univariate. And so it features a bivariate plot that illustrates the relationship between a dependent variable and an independent variable. So it shows how dependent variable changes in response to independent variables and so on. Complementing this center plot, a univariate distribution plot for the independent is positioned horizontally above the bivariate graph, like in this case. And similarly, there is a univariate plot for the other variable as well, like in this case. So that's why it is called joint plot. And how to draw a joint plot? So we can use x and y value parameter. X is, like in this case, x is some feature, and I'm considering the California house prediction data set, and y is total bedrooms, like in this case. And you can also see how actually it is varying. So total rooms is very much related to total bedrooms. So if total rooms are very high, so you can see here total bedrooms are also high, right? So it's a linear dependency between total bedrooms and total rooms, right? Similarly, I can draw two different features, and we can also utilize the categorical data as well. So in this case, I'm using hue. Hue is actually used for the to define a category. So I'm categorizing on the basis of ocean proximity. So I have these ocean proximity values. So you can see here total bedrooms and median house value. So as far as this green color is concerned, so you can see here green is actually inland. So the inland type of property is having low median house value. But if you would see these orange colors, so orange color is for less than 1 hour of ocean. So these are having much you could say variation, and so the lower median value is of this inland property, right? And the higher median value is of related to this near bay property. You could say that the one in blue color. So so in this way you can understand the how features are interrelated and what are their impact in total overall data set. Like in this case, you can see here this orange color is going up, right? So it means ocean value is having higher value, as well as it is having more presence in the data set. Now there is one more special type of plot that we call Violin plot. So a Violin plot is a combination of a box plot and a kernel density plot, that is KDE. It is used to visualize the distribution of numerical data. So you can see here there is a box plot here. Inside this violin, there is a box plot, and it also shows the KDE, kernel density estimation curve, and the width actually shows how much data are how much data are near to the mean value, right? So or median value. Like in this case, the majority of data are centered around the median value, right? So the leaves which are having a higher width. So a violin plot plays a similar role as box and whisker plot. It shows the distribution of data points after grouping by one or more variables. So here we are grouping based on ocean proximity. So unlike a box plot, each violin is drawn using a kernel density estimation of the underlying distribution. So it actually draws kernel estimation, kernel density estimation as well. So how to draw this violin plot? So again, we'll use hue for grouping, for identifying the grouping feature, and then Y as a total bedroom. So this one is the total bedroom, and the data actually it says which data frame you are using, right? So I'm using DF is actually my California horse prediction data set. So this was all about univariate plot. Now let me switch to the Google Colab where I will show you how univariate plots can be drawn. So here I am, I have stored both the data set, that is diabetes data set and housing data set in my Google Drive, right? And I am mounting my Google Drive with Google Colab, and so let me mount this one, and then I am switching to my drive where I have stored my data set. So I have stored my data set into this evolopy folder inside my Google Drive. So let me execute this one. So it would mount and it would ask permission to mount my Google Drive, right? It is now unable to connect. Let me see whether. See here I am trying to mount my drive. So then connect to Google Drive. It will mount my Google Drive. I think there is some issue here. Let me reconnect. So it will ask permission to mount my Google Drive. Yes, connect to Google Drive, and then this is my account. Yes, continue. So in this way, my Google Drive would be mounted. So when it will be mounted, I can use my Google Drive to access any data set. Since I have stored my data set in my Google Drive. So it is trying to access. Yes. Now it has given access to my Google Drive. Yes. Now, so my Google Drive has been mounted here, and I changed my working directory to evolopy where my data set is there, right? Now I will first upload diabetes data set. So you can see this one is the certain information of diabetes data set. Now I can draw some univariate plot. Like in this case, I am using histogram plot here. right? So let me execute this one. It is okay. So first I need to import the libraries Seaborn as well as Matplotlib. Now I would execute this one. So you can see here, this is the histogram, right? I can change its contrast, like let me use 2, and then I can also take some more feature here, like age and as well as blood pressure. Yes, blood pressure. And so I am making a list of features. Now I would use palette. Palette is equal to blue and orange. I can give any color here. Yes, let me execute this one. So you can see here there are 2 different histogram, which is for age and blood pressure, right? Similarly, I can use this particular plot is utilizing the Matplotlib, right? So using the Matplotlib, I can also draw this very similar histogram, but I found Seaborn very interactive and very attractive actually. And also we can draw a histogram for categorical data. So first let me upload California data set, California housing pricing data set. So here this one is the so let me so print df1 dot info. Let me so this one is the housing data set information. So it is having longitude, latitude and so on. So there are different features. So and this one is the categorical data, ocean proximity. So what I will do, I will group the data set on the basis of ocean proximity, and I will try to find out the count of each and every category, right? And then finally I will plot it. So for that purpose, I can use group by method, that we had discussed in last week, and I'm finding the count as well. Here I'm finding the count of each category, right? And then I will use index and values. So where I would use index in hue parameter, right? And y would be the value, or you could say count of each category. And here I have mentioned the color of individual category. Let me execute this one. So here this is the you could say histogram or bar plot of categorical data. And so here is the KD plot, kernel density estimation plot. You could say this one is the kernel density estimation plot. And as far as box plot is concerned, I have used glucose, blood pressure, as well as I can use some more features like df dot and let's say age, right? And here I need to give one more color. So let's say orange. Yes. Let me execute this one. So you could see here there are 3 different features here, right? And also this box plot is for using Seaborn, and this box plot is using Matplotlib, right? So any library you can use as far as plotting is concerned, but Seaborn is aesthetically it is much stronger than Matplotlib. Now I also discussed Violin Plot, right? So here in case of hue, I am using auction proximity and total bedrooms. Here you are having total bedrooms, and this is my data set, whole data set, and palette. Since I am using ocean proximity, so ocean proximity is having different colors, different categories. So let me exclude this one. So you can see here, this one is the box plot. I can change the color as well, right? Similarly, I can use multivariate plot as well. Let me move to the PPT now. Now I'll discuss multivariate plots. So multivariate plots is actually describe the interaction among multiple variables. So multivariate visualization helps to understand interaction between multiple attributes of our data set, how actually the individual features are related with each other, right? And we can utilize these correlation matrix and scatter plots for drawing the multivariate plot. So this one is the matrix plot, or you could say heat map, is used to draw the relationship between different features. It is very important plot as far as correlation between different features are concerned. So it actually indicates relation between two different variables. So you could see here. So how pregnancy, one feature is there in diabetes dataset. One feature is pregnancies, and how it is related to outcome, how much it is actually related to age, how much it is related to other features as well. So correlation matrix shows correlation of a variable whether high or low in respect to another variable. So it says whether they are very high correlated or low correlated. Let's say like in this case, so there is this one is the value, you could say, yeah, this one. So it means glucose and skin thickness are very low correlated, right? But this pregnancy and age is highly correlated, not very much correlated. So it varies from -1 to 1, and negative actually says there is inversely inverse relation between the features, right? If one is going high, then other would going low. It means these are the value would be in negative form, and one says very high correlated. So that's why you could see in diagonal cell you would observe 1, right? So because each attributes is highly correlated with itself, right? Like glucose is very highly related with glucose feature. So that's why they are 1. Now I can use first I need to find out the correlation of each and every attribute. So for that purpose, I would use this correlation method, and then I would use heat map to draw the correlation matrix. Here you could say annotation is true. Annotation it means it would give you this individual values, this individual values between -1 to 1, right? So it is giving, if annotation is false, then these values would not be displayed. Only the cell would be visible, but the value would not be visible. CMap is it is giving different color mapping. So I can use other color mapping as well. So this is the color mapping. It has been indicated as BWR. You can visit this particular website where you would get different type of color mapping, very interactive color mapping that you can use. Then there is one more scatter plot that we had seen in Violin Plot as well. So scatter plot displays data between two features in a data set. It shows how one data variable affect the other variable. Like in this case, you could observe the relation between age and blood pressure. So age and blood pressure, the high values are here, and these high values are actually more between 40 to 60 age, right? And otherwise the majority of values are between 20 and 40, which is the allowed range of blood pressure level. So in this way, we can differentiate between we can correlate between two features. Like here, x is equal to age and y is equal to blood pressure, and I have given green as a color for this plot. Similarly, there is one more plot that is called Pairplot. Pairplot is used to plot each of two features. Suppose if you are having 7 features, so between each and every features, the plot would be displayed, like in this case. So it is giving pair plot between each and every two features. Actually, it is providing pair plot between two features that we have seen. You could say scatter plot. So this one is the scatter plot. So it is giving information between two features, right? So these are certain important matrix plots that we can use for visualization purpose. Let me switch to the Google Cloud. Yes, here you can see here DF is my data frame of diabetes data set, right? First I have calculated the correlation, then I am using heat map to draw matrix plot. So you can see here, this is the matrix plot utilizing heat map. Similarly, I can use this pair plot as well. So it would display plot between between two features. So what are the blue and orange color signify? So blue and orange colors actually signifies the outcome, right? So blue color is for 0 and orange color is for 1, right? Since I have used, let me show you. So since I have used hue as well, right? If I would exclude hue, then you cannot see the colors, different colors actually. So let me draw this one. So now outcome would also the member of this plot, and there would not be any color. It would take some time, right? So because it is plotting every two features of my data set, right? So that's why it is taking some time here, and once it will be displayed, then we can see the relationship between every two features. Yes, so you can see here again the outcome is also a member of this plot, right? And you cannot see the different colors actually. So that's why I use hue parameter in this pair plot. As far as different plotting is concerned, so we can use these different methods: histogram plot, bar plot, KT plot, scatter plot, box plot, violin plot, heat map, pair plots. So we have seen these different methods. So each of these functions provides a variety of customization options as well, which you can tailor to your specific needs. So just to summarize what we had discussed in this particular lecture, so we have seen histogram, how to draw a histogram and the purpose of histogram, bar plot, we discussed bar plot as well, kernel density estimation curve, box and whisker plot, joint plot, violin plot, correlation matrix, scatter plot, pair plot. So we had discussed all these in today's lecture. So I'm stopping here. We'll meet in next lecture. Thank you so much.